Hello and welcome to our video on constructing scatterplots. Scatterplots look like this, always have dots on them, never have the dots joined. Do not join the dots. I'll put that in big letters up here, not highlighting letters, normal letters. Do not join dots. Scatterplots are used when we are comparing two numerical variables. Both have to be numerical. If one of them is categorical, don't use a scatterplot. We always put the response variable on the vertical axis, and the explanatory variable on the horizontal axis. Response goes here, and explanatory variable goes here. This graph here shows the weight of a puppy over the number of days since its birth. So we're starting out at 75 days when it's 75 days old, and its weight starts out at 4.5, and it's getting putting on more and more weight, as you'd expect, as it gets older. Each point on the graph or the scatterplot represents two corresponding data points. So if we look at this very first point down here, that one would be where days is 75. Might try and put a little table up here, and weight is 4.5. And we could keep going through. This next one could be 76, and the weight is still 4.5. And you could keep going all the way through with your data points up until the top one, which looks like day 90. The weight is 6.2. Really important when you have a table that these two are the ones that you plot together, that they're related. That's why we put them next to each other in the table. Here's some steps to drawing your own scatterplot. So this would be if you are given a table of values like this one and you are asked to draw your own scatterplot. First step is to decide which variable is the explanatory and which one is the response variable. And that's really important you get that right, so you know which to put on which axis. And it does matter for the analysis that we're going to be doing of scatterplots. Second step is to draw and label your axes. So you draw these two straight lines with a ruler, label them, days, weight, or whatever your variables are. And make sure you've got the explanatory variable on the bottom and the response variable on the side. You then need to number and label the numbers on your axis. You need to make sure these distances here are equal. You couldn't go from 70 to 80 for the first step, and then from 80 to 85, so you would be jumping in 10 for the first step and then 5 for the second step. Not allowed. These need to be equal distances. So this one is going up by 5s, and this one, they don't have to be the same. They can be the same, or they might be different. This one is going up by 0.5, or a half each time. Your final step is to draw a dot for each point. And the way we do that, we take the x-axis, or the horizontal axis, or the explanatory variable, point, which is 75, we find that along the horizontal axis. So we're plotting this point, and then we go up to where the response variable is 4.5, and you just put a dot. Make sure your dots aren't too large, make sure they're not too small. We don't want crosses, we don't want huge coloured in dots, because we need to be able to accurately see whether it is at 4.5 or slightly higher or slightly lower. If you're not sure if your dots are okay, please come and show me and I'll let you know how you're going with that. Here's an example for you to have a practice with. Following data was found when answering the question, is the number of hours of homework completed related to test scores? The test scores are along the top and the homework in hours is along the bottom. You need to follow these steps and see if you can draw your own scatter plot. Pause the video now. Okay, first thing I need to decide is which is the explanatory and which is the response. So my two variables are homework in hours and test scores. Does homework cause test scores? So more homework causes higher test scores, or do higher test scores cause more homework? I think it's the first way. More homework causes higher test scores. That's what we would be suggesting. So this is our explanatory variable and this is our response variable. So once we've got that, we can put our explanatory variable on the vertical axis and our response variable on the horizontal axis. And I've labeled them homework and test. I've just put a little X here and a little Y here to show you that this is the X-axis and this is the Y-axis. Next step, number the axes with equal distances between marks. So I've looked at these numbers for test results and the lowest is 44. So there's no need for me to start at 0. So I've put a little jagged lightning bolt to show that I'm not starting at 0, I'm starting at 40. I'm going to go up in 5s, 45, 50, all the way to our highest number is 93. So I might just even it out and go to 100. Could have stopped at 95. It's completely up to you how you do that, as long as all the data points will fit in. Homework in hours goes from 5 hours up to 50 exactly. So I'll probably start at 0 for this axis, go up in 5s, and I can finish exactly on 50. Step number 4 is to draw a dot for each point. So the first point here is test score is 61, so I'll go along the test score, find the 61. And then homework is 35. 61 up to 35, and I put a little dot. The computers put it as a square, but you need to put it as a dot. Put a little dot there, and to remind you, I'm going to put this here, 61, 35, so you can see which one it relates to. Our second dot is 95 and 50, so we go up to 95 and 50 is there, put another dot. And then you need to keep going with all of your other points. So you should end up with a scatter graph that looks something like this. Do not join the dots ever. Leave it like this. This is your final scatter plot, and this is what it looks like. We might do some analysis to it later, but if you're just asked to do a scatter plot, it will look like this without any lines or any joining of dots. Thanks for watching the video.